So in this video, we're going to be solving polynomial equations. So examples of polynomial equations are going to be like x to the fifth plus 4x squared minus 3x equals 0. Okay, these are polynomial equations when you have a polynomial expression in which you now have an equal sign, and when you are solving, you're finding the input when the output is a specific value. Now, some things to go over. You're going to want to look at your polynomial in the standard form of a polynomial equation. Okay, remember, standard form is largest exponent to smallest, and then you want to make sure, okay, that it is set equal to 0. Okay, now we need to learn about something that is going to be extremely helpful when we are solving polynomial equations. Okay, the fundamental theorem of algebra. So what the fundamental theorem of algebra says is that if you have a polynomial function, okay, we'll call it p of x with degree of at least 1, okay, then you have at least 1 root. Now, we talked about, in a previous video, we talked about root solutions, okay? Roots are just talking about when you're specific to, root is the value of x when the output of the function is 0. Okay, solutions, remember, is when you are solving for x when your equation is set equal to 0. So if you have a polynomial with degree of at least 1, you will have at least 1 root. Now, what's really important is the corollary. Okay, it's kind of like an addition. Okay, it's like an extension of the fundamental theorem of algebra. And what the corollary says is, if p of x has a degree of n, okay, because it has the ability to change, so if the degree of the polynomial is n, then p of x has exactly n roots. So we can think of this also as solutions. So what this means is, okay, this is a 5th degree polynomial. So that means that there are going to be 5 total solutions. Whatever the degree is, that's how many total solutions. But you have to include what's called multiplicity. You can have the same answer more than one time, okay? But that has to be included in your total amount. All right? So, for example, when we had a quadratic and we were solving a quadratic equation, okay, we were getting 2 real roots, right? We were getting 2 imaginary roots, or we were getting just 1 root, but think about it, you were getting the same solution twice, okay? So that technically counts as 2. So every time you solve a quadratic, you're technically getting 2 answers. They're either, we all know all about it, they're either going to be 2 real, 2 imaginary, or it's going to be 1 distinct answer, but you get that same answer twice, okay? So, why don't we start solving? But you have to keep in mind, okay, that here's the first thing you have to keep in mind. Whatever the degree is, that's how many solutions you get in total. That's the first thing you have to keep in mind. The second thing you have to keep in mind is the only types of polynomials you know how to solve. You know how to solve all linear and all quadratic equations, okay? So the first one we'll solve will be x to the third plus 2x squared minus 5x minus 10. So what you want to make sure is, you want to make sure that your polynomial is in standard form. So is it set equal to 0? Yes. So now, look at what the degree is. The degree of this polynomial is 3. That means we are going to get 3 answers, okay? We're going to have 3 solutions here. It might be the same solution 3 times, but, okay, we're going to need to get 3 solutions. Now, we do not have a magic formula that we can put in the coefficients and pop out our 3 answers. The only thing we have is we know how to solve all linear and we know how to solve all quadratic equations. So what that means is this is the standard form of a 3rd degree. What we need to be able to do is we need to be able to factor down to linear and quadratic factors. Otherwise, we will not be able to get all 3 of our answers. So, if you look at this 3rd degree polynomial, it's got 4 terms. So the type of factoring you should be trying here is factor by grouping. X to the 3rd plus 2x squared plus negative 5x minus 10. Okay? Factor out the greatest common factor in each set. X squared. In this, it's negative 5. And you're left with x plus 2 times x squared minus 5 equals 0. So, notice, you just got a 3rd degree polynomial to be written as a product of a linear factor and a quadratic factor. One of the solutions is sitting right here, and the reason we can now solve is because we're using the 0 product property. Remember, if a product is set equal to 0, okay, then any of the quantities, if it's 0, the entire left-hand side would be 0, making this statement true. So, one of your solutions sits in the linear factor, and 2 of your solutions sit in your quadratic factor. So what you have to do when you're solving polynomial equations, you need to be able to factor it down so that you can solve what you know how to solve, which are linear and quadratic equations. So what makes x plus 2 equal 0? Okay, I could take away 2. That gives me x equals negative 2. So one of my solutions is negative 2. And then I have x squared minus 5 equals 0. Now, I could use the quadratic formula if I wanted to, but there's something called the square root property, right? Only the square root property, in which I can add 5 to both sides, and I get x squared equals 5, and then I take the square root of both sides, and I get x equals plus or minus the square root of 5. So here are my 3 solutions: negative 2, square root of 5, and negative square root of 5. If I wanted to, I could plug them in and make sure that the left-hand side equals the right-hand side. Now, this is the square root property. It only works when you are taking the square root. Okay, not just any root. It's only the square root property. Okay, so let's do another one. Number 2, 8x to the 3rd equals 27. This one, people love to say, I'm going to divide by 8, okay? I'm going to divide by 8, and then I'm going to take the cubed root of both sides. And I get x equals the cubed root of 27 over the cubed root of 8. I get 3 halves, and I'm done. My answer is 3 halves, okay? That is wrong, okay? Not that this isn't a solution, but we just talked about how many solutions we should be getting if we are specifically talking about solving a polynomial equation. You know you're solving a polynomial equation if you have a polynomial expression. Remember, polynomial expression is you have integer exponents, okay? And they're positive, or I should really say non-negative integer exponents, okay? Because x to the 0. So if this is a 3rd degree, okay, I should be getting 3 solutions. If all you did was just take the cubed root, all you got was 1 real answer. So that means that you did not do this problem correctly. You're missing 2 of the answers. And the reason you're missing 2 of the answers is because there's no special formula that you can use to find anything greater than a degree 2. Which that means is you need to put this in standard form, And what you need to be able to do to get all three answers, you must be able to factor this down, okay, to linear and quadratic factors. Now, will all polynomials be able to be factored? No. So are you going to be able to solve all polynomials by hand? No. But I'm giving you ones that you will be able to, as long as you can write them as linear and quadratic factors. So this is two terms, okay? We look through our factoring patterns for two terms. We have the difference of squares, the difference of cubes, the sum of cubes. And we should also see if there's a greatest common factor here. There's no greatest common factor, and this fits the difference of cubes. So what to the third is 8x to the third? That would be 2x. What to the third is 27? That would be 3. So we factor according to the difference of cubes factoring pattern, which is this would be a minus b, so it's going to be 2x minus 3, and then remember this is a squared plus ab plus b squared. So a squared, 2x squared, that's going to be 4x squared, plus a times b would be 6x, plus b squared, 9, equals 0. So look, we got this standard form of a third degree down to a linear factor and a quadratic factor. We know how to solve all linear factors, and we know how to solve all quadratic factors. You don't even have to worry about trying to factor again this quadratic factor, okay? Because you know how to solve all quadratics. So 2x minus 3 equals 0. Add 3 to both sides, we get 2x equals 3. Divide by 2, we get x equals 3 halves, okay? So here's that one solution that we got right here, okay? But now you would be wrong if that's all you said, because there are actually two other values that can make this 0. And they're sitting inside. Those solutions are coming from this factor, okay? So I'm going to use the quadratic formula. -6 plus or minus the square root of 6 squared minus 4 times 9 all over 2 times 4. So this is going to be -6 plus or minus the square root of, and let's get the value of the discriminant here. That's going to be -108 all over 8. Notice, that means that two imaginary solutions, okay? We're about to get two imaginary solutions here. This is going to be -6 plus or minus the square root of 108 times I all over 8, which right now we haven't gone over simplifying radicals, so we're not going to worry about that, okay? This will be -6 over 8 plus or minus the square root of 108I over 8, and we could simplify this to be -3/4 plus or minus the square root of 108I all over 8. Remember, the I is not inside of the radical. It is not part of the radicand. It's sitting outside. So here are your three solutions. 3 halves, and then -3/4 plus this, -3/4 minus this. Okay, so here are your three solutions. This is wrong. You cannot do that. Okay, number 3. X to the 5th equals x. For some reason, people like to say, I'm going to divide by x, because there's x's on both sides. You never divide by a variable. If you were dividing by a variable, okay, you are taking out a solution. If you are dividing by a variable, you are taking out a solution. You never divide by a variable. When you have an equation, you are allowed to divide by a constant, but not a variable. So, next, someone might try and take the 5th root of both sides. No, do not do that. Always put this thing in standard form and then go from there. So if I put this in standard form, I cannot divide by x. I can take away x from both sides. Okay? And so now we've got x to the 5th minus x equals 0. So now you set your polynomial equation equal to 0, and then you say to yourself, what is the degree? The degree here is 5. That means this has 5 solutions. There is no magic way of just taking the 5th root, okay? There is no fifth degree formula, you have to factor this down, okay, to linear and quadratic factors. So let's see if we could do that. X to the fifth minus x. First, check to see, okay? Is there a greatest common factor? Yes, the greatest common factor here is x. So this is x times x to the fourth minus 1 equals 0. Now, oh, x to the fourth minus 1 equals 0. People like to say this. Ready? Well, I'm going to take x to the fourth, I'm going to add 1 to both sides, I'm going to take the fourth root, and I'm going to get x equals 1. Because 1 to the fourth minus 1 is 0. Yes, that's true. But how many answers did you just arrive at because you took the fourth root? You got one answer here. And when it's a fourth root, it's technically the positive and the negative, okay? Because positive to the fourth and negative to the fourth are going to give you the same output. But this is a fourth degree. How many solutions should you be getting from a fourth degree? 4, not 2. That is wrong. The only way to get your solutions is to knock this thing down. This is x to the fourth minus 1 is the standard form of a fourth degree factor. You must knock that down to linear or quadratic factors. So, one solution is sitting here, 4 solutions is sitting here. You can't solve a fourth degree. You must be able to keep factoring, otherwise you're never going to get those 4 answers. So let's look. 2 terms, so we should now look for difference of 2 squares, difference of 2 cubes, sum of 2 cubes. This is the difference of 2 squares. This is x squared to the second minus 1 to the second. So this factors to be x squared minus 1, x squared plus 1, and there's still a linear factor sitting outside, okay? A linear factor is not a constant factor. A constant factor is when you just have a value of a number and it doesn't have a variable with that factor. That means it doesn't have the ability to change. So if we look, we have a linear factor, we have a quadratic factor, we have a quadratic factor. One solution is coming from here, 2 solutions are coming from here, 2 solutions are coming from here. You know how to solve all linear equations and all quadratic equations, so that's what we do. We set each of these factors equal to 0. So what makes x equal 0? What makes x squared minus 1 equal 0? And what makes x squared plus 1 equal 0? Well, what makes x equal 0 is 0. That's why you never divide by x. That means that 0 is a solution. Now, what makes x squared minus 1 equal 0? Well, add 1 to both sides. And do we have a square root property? Yes, we do. Because this is only 2 answers. This is plus or minus 1. And then x squared plus 1 equals 0. Take away 1 from both sides. Take the square root, and the square root property tells us this is plus or minus the square root of negative 1. This is imaginary, right in terms of I, so this is I. So here are our 5 solutions. 0, plus or minus 1, plus or minus I. If you just took the 4th root, all you would get here is plus or minus 1. You'd never see this plus or minus I. Here are all 5 solutions to this problem. All right. Next one, that was 3, number 4. Okay, 2x to the 4th plus 2x squared minus 10 equals x to the 4th plus 5. So, first off, you want to see it in standard form. So I'm going to take away x to the 4th from both sides. I'm going to take away 5 from both sides, so that one side is set equal to 0. That gives me x to the 4th plus 2x squared minus 15 equals 0. This is a 4th degree. That means this has 4 solutions, okay? You must be able to factor this down. Otherwise, you will not be able to find your 4 solutions. So, you have to be able to factor it all the way down to linear and quadratic factors. So let's look. No greatest common factor. Okay, so now we say 3 terms. So if this is a 3-term 4th degree, this must be able to be written in quadratic form and be able to use the AC method if we are going to be able to factor this. So can we write it in that form? Yes. This would be x squared squared plus 2x squared minus 15. So yes, I can use the AC method because remember, these have to be the same. So what two numbers multiply together to give me negative 15 and add together to give me 2? That's going to be 5 and negative 3. So this factors to be x to the 4th plus 5x squared minus 3x squared minus 15. That's going to be x to the 4th plus 5x squared plus negative 3x squared minus 15. So that's going to be x to the 2nd, which factor that out, gives you x to the 2nd plus 5. We're going to want to factor out a negative 3 here. That's going to leave us with x squared plus 5. And then in the last step, I'll just write it here. Factor out the greatest common factor between these two quantities, which would be x squared plus 5. And then what's left? X squared minus 3. So this 4th degree in standard form factored to be the product of two quadratic factors. So you know how to solve all quadratic equations. So that means we can now find these two answers, and we can now find these two answers that are sitting in each of these factors. So take away 5 on both sides, and we get x squared equals negative 5. Take the square root, and we get x equals plus or minus the square root of negative 5, which would be x equals plus or minus square root of 5i. Add 3 to both sides. Take the square root. We get x equals plus or minus the square root of 3. Here are your 4 solutions to this 4th degree polynomial. So you need to make sure that when we are going through this, okay, that whatever polynomial you end up with as its degree, that's how many solutions you get. You cannot find the solutions until you have factored it down to linear and quadratic factors. So here's the problem. Number 5. We have, we're going to solve x to the 3rd plus 8x squared plus 14x minus 3 equals 0, and you're going to be given negative 3 is a solution. It could also say negative 3 is a root. If you're asked to find the roots, you're asked to find the values of x when the output is 0. Now, if you look at what you have here, okay, look at this 3rd degree polynomial. X to the 3rd plus 8x squared plus 14x minus 3. Okay? I try to factor this by grouping, and I'm going to get x squared times x plus 8 plus 1 times 14x minus 3. Is this 3rd degree polynomial factorable by the techniques we have? No, it's not. So we would never be able to solve this. We would not be able to get all 3 solutions by hand. Could you do something else to try and get your solutions? Yes, we'll get to that eventually. But we're given a clue. We're told that one of the solutions is negative 3. That means if we plug in negative 3, we're going to output 0. Okay? So what that means is, if negative 3 is a solution, okay, that means that one of the factors of this 3rd degree polynomial, okay, one of the factors had to give us an answer of negative 3. So what is the factor that would produce the one solution of negative 3? That would be x plus 3. So one of the factors of this, if you know what the solution is, you know what one of the factors are. Now, how do I find, if this is a linear factor and this is a 3rd degree, that means this is a quadratic factor. So how can I find the missing factor? Well, I divide out x plus 3 from my 3rd degree polynomial. So I'm just going to use synthetic division because I meet the requirements to use it. I don't need any placeholders. Bring down the first, right? 1 times negative 3 is negative 3. Add it up, 5. 5 times negative 3 is negative 15. Add it up, negative 1. Negative 1 times negative 3 is 3. This obviously better be 0 because you were told that this was a solution. So this isn't a guess and check, is x plus 3 a factor? You are 100% sure that it is. So this is the constant. This is x to the first. This is x to the second. So it would be x squared plus 5x minus 1. This is not factorable, but that's okay. It doesn't need to be because you know how to solve any quadratic equation. We can just use the quadratic formula. So that's going to be x equals negative 5 plus or minus the square root of 5 squared minus 4 times 1 times negative 1 all over 2 times 1. So this is going to be negative 5 plus or minus the square root of, that's going to be 25 plus 4, so that's going to be 29 over 2. So here's our answer. So we already it says given negative 3 is a solution. So one of the solutions is negative 3, okay? And the other two solutions are right here. Negative 5 plus or minus the square root of 29 over 2, okay? So that is it for solving. What we're going to get into are what are some of the techniques in the next video. What are some of the techniques you can use when you go to solve a polynomial, except it is not factorable, okay? Because as of right now, if it's not factorable and it's greater than degree 2, your polynomial, you would not be able to solve and get all of its solutions.